In episode 32 of the CySec101 series, we're going to go through the fundamentals of the SQL, the structured query language, and this is all a part of the web hacking module of the CySec101 pathway of TryHackMe, the cybersecurity 101 pathway. And we have covered web application basics, JavaScript essentials. We are in SQL right now, and then in the next couple of videos, we're going to go through Burp Suite and of course, OWASP top 10. And so in today's video, we're going to be going through some really interesting portions of this. Obviously, it's an introduction to SQL, so we're going to cover the very basics, the fundamentals, and then we're going to go through the concept of databases in general, what SQL actually is and how we can query databases and table statements, CRUD Operations. I think it could be pronounced CRUD Operations, but I want to say it's CRUD Operations. We have clauses, operators, functions, and then of course the conclusion, and then you will be dismissed for today. If you'd like to support this channel, consider joining Hackaholics Anonymous, the premier community for security professionals and hackers. We have 4 tiers: the supporter, agent, guardian, and master, and each tier gets their own Discord server and early access to content. And the agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automation, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the SQL fundamentals room. We cover a lot of stuff in cybersecurity, but few things are as ubiquitous as databases. That's a very powerful word right there. Whether you're working on securing an application, working in a SOC setting, or using a SIM, configuring user authentication and access control, using malware analysis, threat detection tools, and so many other things, you will most likely be relying on databases in pretty much all of those capacities. And on the offensive side of security, it can help to better understand SQL vulnerabilities like SQL injections and create queries that help us tamper or retrieve data with a compromised service. On the defensive side, it can help us navigate through databases and find suspicious activity or relevant information, and it can help us better protect a service by implementing restrictions when needed. Because databases are ubiquitous, it's important to understand them. And this room will be the very first step in that direction. So we'll go through the basics of databases, covering key terms, concepts, and different types before getting to grips with SQL. The prerequisites would be the Linux fundamentals, and there have been so many videos on Linux, including an entire Linux Plus playlist. So there's a lot of stuff that's available on this channel. If you have not learned anything about Linux, there's Linux fundamentals videos inside of the CySec101 playlist. I did an entire Linux SysAdmin video that is the most popular video on this channel, and then of course there's the Linux Plus playlist on this channel. So there's a lot for you. You're definitely not lacking as far as Linux content is concerned. So the objectives here are to understand what databases are, as well as key terms and concepts, understanding the different types of databases, understanding what SQL is, and being able to use SQL CRUD operations, SQL clauses operations, SQL operations in general, and be able to use SQL operators, and then of course SQL functions. So that is going to be the gist of what we're going to be talking about in this particular video. So let's jump into Databases 101. Databases are an organized collection of structured information or data that's easily accessible and can be manipulated or analyzed. The data can take many forms, like user authentication data, like usernames and passwords, which are stored and checked against when authenticating into an application or a site, like TryHackMe, for example. There's user-generated data on social media like Instagram and Facebook, where the data is user posts, comments, or anything like that. And then they're collected and stored, as well as information such as watch history, which is stored by streaming services such as Netflix and used to generate recommendations. So there's a lot of different ways that you can use databases, and you can contain many different things inside of those databases. It's not just massive scale businesses that use them. Smaller scale businesses, when setting up, will almost certainly have a database as well to store their data. So the different kinds of databases is essentially our segue that we're going into. So knowing what they are would be great to understand that there's a lot of different implementations of them. We can build a lot of these different types of databases. And for this room, we're just basically going to focus on two types, which is the relational database, which is SQL, or non-relational databases, which is no SQL, right? So relational databases are table-based. They relate to each other. The various values of the database are relating to each other. Non-relational databases will be things like databases that have key value pairs or are graphs or just a wide column or a document. So a relational database is storing structured data, meaning the data is inserted into databases follows a structure. So the data collected on a user consists of the first name, last name, email address, username, and password. When a user joins, an entry is made in the database following that specific structure right here. And then we have the structured data is stored in rows and columns in a table, all of which will be covered in a few minutes. And then we have relationships that can be made between two or more tables, for example, user and order history. And then the term relational comes in. So you can have the user table that stores all of this information. And then you have the order history that also stores information about various orders and how it connects to each individual user's activity, right? Then we have non-relational databases that instead of storing data like we discussed, they store in non-tabular formats. For example, documents are being scanned, which can contain varying steps or varying types and quantities of data, and they're stored in a database that calls for a non-tabular format. And this is potentially what that could be. This looks like JSON format. So we have key value pairs. So we have the ID, and then this is the value for it, and it's separated by a comma, and then we have the next key, and the value for that is going to be here, separated by a comma, and so on and so forth. And so usually when you see these squiggly braces right here, you can, for the most part, deduce that this is a JSON type of a format. And in terms of what databases should be chosen, it always comes down to the context in which the database is actually going to be used. So relational databases are often used when the data being stored is reliably going to be received in a consistent format where accuracy is important, like when processing e-commerce transactions. Non-relational databases are better used when the data being received can vary greatly in the format, but needs to be collected and organized in the same place, like a social media platform collecting user-generated content. Inside of a relational database, we have the tables, rows, and columns, right? So we'll focus on relational stuff for the most part, because that's where SQL really shines. And by understanding what tables, rows, and columns are, you'll be able to get everything else as well. So all the data stored in a relational database is going to be inside of a table. For example, a collection of books in stock at a bookstore might be stored in a table called books. And then you have these columns. So you have the ID column, the name column, the published date. And then each row represents a separate entity. Android Security Internals, Bug Bounty Bootcamp, Car Hackers Handbook, so on and so forth, right? So when creating this table, you need to define what pieces of information are needed to define a book record. For example, the ID name and published date. These would be your columns. When these columns are being defined, you would also define what type of data this column would actually contain. If an attempt is made to insert a record into a database where the data type does not match, it is rejected. The data types that can be defined can vary depending on what databases you're using, but the core data types used by all include strings, a collection of words and characters, integers, floats, decimals, and times and dates. Once a table has been created within a column defined, the first record would be inserted into the database. For example, a book named Android Security Internals with the ID of 1 and a published date. Once inserted, this record would be represented as the first row. We have primary and foreign keys. So once a table has been defined and populated, more data may need to be stored. For example, we want to create a table named authors that stores the authors of books sold in the store. And this is a very clear example of a relationship. A book that is stored in the books table is written by an author that's stored in the authors table. If we wanted to query for a book in our story, or our store, I think, but also have the author of that book returned, our data would then need to be related somehow. We do this with keys, and there are two different types of keys. So the ID, in this case, would be a primary key, and the author could be a foreign key, right? So author ID here could be a foreign key, but then the ID on the authors table could also be a foreign key. So in this table, the primary key would be the ID column, and then the author key would be a foreign key. And then in the authors table, the ID would be a foreign key as well. So primary keys is used to ensure that the data collected in a certain column is unique. That is, there needs to be a way to identify each record stored in a table. A value is unique so that the record is not repeated by any record in that table. So think about matriculation numbers in a university. These are numbers assigned to a student so they can be uniquely identified in records, because unique students sometimes have the same name. So a column has to be chosen in each table as a primary key. In our example, ID would make the most sense, as an ID can be uniquely created for each book, whereas books have the same publication date, or in rarer cases, they have the same title. Note that there can only be one primary key column in a table. Foreign key is a column or columns in a table that also exists in another table within the database, and therefore provides a link between the two tables. In our example, thinking about the author ID field to our book table, this would be then act as a foreign key, because the author ID in the book table corresponds to the ID column in the author table. So foreign keys are what allow the relationship between different tables in relational databases, and there can be more than one foreign key column in a table. So what type of database should you consider using if the data you're going to be storing will vary greatly in its format? And if it's going to vary, that would be a non-relational database. Hopefully I spelled that right. And then there's probably a hyphen that needs to go here. What type of database should you consider using if the data you're going to be storing is reliably the same? And that would be the relational database. And in our example, once a record of a book is inserted into the books table, it would be represented as in that table. It would be represented as a row in that table. Which type of key provides a link from one table to another? And that would be our foreign key. That's definitely not how you spell foreign. Foreign, right? Like that. Very good. And which type of key ensures a record is unique within a table? And that would be the primary key. So very good. We got the basics of databases. Now let's talk about SQL. So understanding what a database is great, but we need to understand how the rubber meets the road, so to speak. So how would you make your first table and populate it with data? What would you use? Databases are usually controlled using a database management system, serving as an interface between the end user and the database. The DBMS is a software program that allows users to retrieve, update, and manage the data that's being stored. Some examples include MySQL, MongoDB, Oracle Database, and MariaDB, and they all, for the most part, operate with SQL. So SQL, the benefits of it, and the concept of the relational database. So SQL stands for the Structured Query Language, and it's a programming language that can be used to query, define, and manipulate the data that's stored inside of a relational database. It's almost as ubiquitous as databases themselves, and for good reason. And these are just some key benefits. So it's fast. Relational databases, aka those that require SQL, can return massive batches of data almost instantaneously due to how little storage space is used in high processing speeds. They're easy to learn. So unlike SQL, it's written in plain English. So unlike other languages, unlike other programming languages, SQL is written in plain English, which makes it very easy to pick up. The syntax is very easy, basically. It's reliable, so they can guarantee a level of accuracy when it comes to data by defining a strict structure into which the data sets must fall in order to be inserted. And then it's flexible because it provides all kind of capabilities when it comes to querying a database, which allows you to perform vast data analysis very efficiently and quickly. So now that we have this, it's time to actually kind of start working with it. And I've already started our virtual machine here. So it's going to be in our split screen, and then we're just going to start essentially running these various commands that we have over here. So I'm going to open up my terminal here, and the first command is mysql u root p. So once prompted for the password, enter TryHackMe as the password. And that's pretty much what it's going to start, and it's actually going to start the MySQL command line so that we can actually start working around and messing with it. So we're going to do MySQL. The U for the user is going to be root, and the password, we're going to press enter, and it's going to say enter the password, and it's going to be TryHackMe, all lowercase. And now I have the MySQL command line, which means it worked. So the question here is, what serves as an interface between a database and an end user? And that is the DBMS, I want to say, the Database Management System. What query language can be used to interact with a relational database? And of course, that is SQL. So let's actually start running some commands here. All right, so for the most part, for all of these statements and everything that we're going to be running, instead of just reading through them and then running through them, I'm going to just start running through them, and then we're just going to look at our command line and use that as an example of what we're going to be running with, right? So we'll go through the create database stuff, and then we're going to show the databases and then use databases and drop databases, so on and so forth. So this is going to be nice and easy to run. So I will open this up in a new window. It's going to be in full screen mode. And then from here, we're just going to zoom in on our terminal, and then we're just going to run everything in our primary window, which is going to be this window. I'm just going to drag this out to to my second monitor, so I can go ahead and kind of run these things or read them as I run them, so that you can just basically see what I am currently running. So it should be fairly fun and easy to operate this thing. So the very first thing that we want to do is we want to create a database, right? So that's the very first thing. If you don't have one, obviously you need to create one. So MySQL ends up being the specific I guess software that we're gonna end up using, the database manager, DBMS. This is the database manager that we're gonna end up using to create our database. So the very first command is to create a database, and I think you can run it without actually doing these things in caps lock, but for the most part, I'll just do it in this particular case. So we'll do test db, and then we're gonna do a semicolon, and then we're gonna press enter, and it says one row affected. And so let's see, we'll do create another one. So I'll do it in lowercase. Let me see if it actually works if I do it in lowercase. So test database, and then we'll do that. And okay, so it also worked in lowercase. I think it'll work whether it's in lowercase or uppercase, but in the in SQL, the syntax usually is that whatever the command is, they do it in uppercase to be able to differentiate from the value. So for example, in this case, the database name would be the value, and then these are the commands, right? So you're creating a database called test_db, and that when you look at this as a full command, you're like, okay, the ones that are in caps lock are the actual commands, and then the lowercase stuff are the values that we're playing around with. So so now we have these things, right? So if we have that, then I can do show databases, and then semicolon, press enter, and it'll show me the various databases that I have. And then I have test DB right here, and I have test database right here. These are the two that I made. There's THM books, books2, tools DB. There's the sys, task 4, performance schema, MySQL information schema. And of course, there's a flag already here that will probably be one of the answers to the questions that we need to run. So, all right, so now that we have this, what we need to do is we need to kind of use a database. So let me see if clear works here. Clear does not work. Clear lowercase doesn't work either. So when you are in the MySQL command line, the basic syntax of Linux does not seem to work. So what we're going to do is we're going to use our first database, which is the THM book market _db. I don't have this here. I wonder if this is one of the ones that they made. Yeah, that's actually the second one that they made inside the example. So since I don't have that, I'm just going to use the one that I made, which is going to be the test database. So I'll use test database, and that's going to be the database that we're going to use. So the database has now been changed to our test database database. So what we can do is we can also drop a database. So once you no longer need it, or maybe it was created for test purposes and it's no longer required, we can actually remove it by doing the drop statement. And to remove it, we would just use drop database and then give it the database name, and then you'd be able to drop that database. So as an example, I could do drop and then do database. And maybe I need to kind of like bring this lower a little bit so you can actually see what's going on. So we'll do drop database and we'll do test_db and press enter. And I got to do that semicolon is very important. And then we press enter. And now it says, okay, those are done. So show databases, let's see. And now we have that the test DB database is no longer here, right? So that's been removed. So we can now create a table inside of the database. So the one that we're working with right now is our test database. That's the one that we switched ourselves into. So we can actually start creating various elements of that. So the first one would be to create a table, and then it would be test. I'll do test table, and then I can do an open parentheses, and then I can do enter, and now I have a new line. So it could be example column 1, and then data type, comma, enter, example column 2, and then data type, and then example column 3, and then data type, like that. And then no comma required for the last one. We'll close out the parentheses, do a semicolon, press enter. And now it says you have an error in the syntax. Check the manual that corresponds with this. Example column 1, data type. Oh, you know what? I'm literally just typing what they put over here. And I think I'm supposed to be doing like example column 1, the data type should be something other than the actual phrase data type. Yeah, so I think obviously I did this incorrectly. I was literally just reading through it and I just started typing it out. This was just kind of a template of what we're supposed to be doing. And I feel like I've already created an example column data type because 2 and 3 didn't work. So I'm just going to start fresh, and we're going to drop the database, and then we're going to drop the test database that we have here. And that's now going to be done. So if I do show databases, just to confirm here, we have dropped it. So we're going to create a database, and then we're going to call it, we'll do THM books as they did. And it already literally has one called THM books. So we'll do another one, and then we'll just call it THM books 3. So that'll be the one that I created. So THM books 3 is good, and then we're going to do use database, and then THM books 3, and there you go, an unknown database. So we're going to do use THM books 3. I think that's the command. There we go. So database has changed, and now we are inside of THM books 3. So now we can actually create a table, and we will call it the books inventory, or book inventory. And then with this one, we can actually start adding some key value pairs here. So okay, that was a little bit challenging for whatever reason. I couldn't get caps lock going. So hopefully this actually works. If I press enter, this is supposed to create a table called book inventory, and it has 3 columns: the book ID, the book name, and the publication date. And book ID is going to be an integer. So these are the various things that we need to add to it. So it's going to be an integer, and it should only ever be a number, which is going to automatically increment for us, meaning the first book inserted would be assigned a book ID of 1, and the second book would be book ID 2, and so on and so forth. And then book ID itself is set as the primary key. Okay, so that's what all of this is right here. And these are the various values that would go with that. And then we have book name. And of course, book name is the data type varchar255. meaning that it can have variable characters. So varchar or varchar, I guess, it would be variable characters, which means text, number, punctuation, and a limit of 255 characters is set. And not null right here means that it cannot be empty. So if someone tries to insert a record into this, but the book name was empty, it would be rejected. And then the publication type is just set as the date. So these are the various elements of this. And now we can press enter and everything is all good. We didn't get any error messages, so we are good in this regard. Now inside of this particular table that we're in, we can actually do show tables, and it should show us the table. So tables in THM books 3, and then there's the book inventory, right? So that is our table that is available. So we can now show the contents of that table, and we would use something which is called the describe command. So if I do describe, and then we would do describe book inventory, press enter, and we see that we have these various fields, right? So we have the book ID, which is an integer. It's not null, meaning it can't be empty. It's the primary key. The default right now is null, and it automatically increments. And then we have the book name, which is a variable characters. It's also not null. It's not the primary key, and the default is null, but it can't be empty. That's what this piece right here says, the null part right here. And the publication date, it can be empty, I guess, because we didn't really specify that. And that's basically it. So these are the descriptions of the various columns inside of our book inventory table. Okay, so we can now alter the book inventory table. So once you've created it, there may come a time where you need to, when you need for the data sets to actually change, and you can alter it using the alter statement. And we can do something like, add a page count column to it, right? So the alter statement can be used to make changes such as renaming columns, changing the data type in a column, or removing a column. So now I can do this. I can do alter and do the table itself, which is going to be the book inventory table. And then now we're going to add page count, and then it's going to be an integer, and then we're going to close that. So that should be all good. And now we can try the describe one more time. So describe book inventory, and there should be a page count. There we go. So now we have a page count as well. And that is also another integer because page counts are only integers, right? So that was really it. So we created a table. We created, we did. We created a table inside of that, or we created a database, my bad. We created a database, then we created a table inside of the database. Inside of that table, we added these various fields or these columns. And for each column, we were able to add specific elements to it. For example, making sure that it's only an integer and it's the primary table or the primary key, it automatically increments. And then this one has variable characters, maximum 255 characters, so on and so forth. So, and then we were also able to alter the book inventory table by adding a page count, which is another integer. And from there, now we have this full description right here that has 4 columns, and that's our first official table. So now what we can do is we can just go ahead and drop the table, which is going to be book inventory, and now we've gotten rid of our book inventory. So we'll do show databases, and then we have no longer the table was inside of the THM books. So that's what that was. So the database is fine, but the table that we just dropped was the book inventory table. So if I actually go and do show tables inside of book inventory, I no longer have that table because I just deleted the table, and it's done again with the same command. So you could do drop database and then drop the database name, or you could do drop table and then drop the table name. Now, using the statement that we've learned to list all the databases, there should be a flag, which is this. So there's going to be our first question right here. So we're going to copy this, and we're going to go right here and we're going to paste that as our first answer. And it says in the list of table of available databases, you should also see a task for database. Set this as the active database and list all of the tables in it. What is the flag that is present here? So we're going to go back here and we're going to set or we're going to use task for. So use task for DB, and that's been changed. Okay, very good. Then we can also do show tables, right? So there we go. And that is the flag for task for database. And copy that. And we're going to go here and we're going to paste that. And that would be that flag. Very cool. So let's talk about CRUD operations. So CRUD stands for create, read, update, and delete, which are considered the basic operations in any system that manages data. And we can explore all these things when working with MySQL. So in the next couple of tasks, we're going to be using the books table that is part of the database THM books. And we can access it with the statement THM or use THM books. So that's going to be the table that is going to be the primary table that we will be using for the following few exercises. So if we do show databases one more time, we see that we have THM books. So we're going to use THM underscore books, and that will be our new database that we are going to be using for the CRUD operations that we got. Okay, so the first part that we want to go through is to go through the create operation, which is insert, right? So the create part of CRUD, that's C, is done with the insert command, and it'll create new records in a table. In MySQL, it can be done using the insert into. So we can do insert into books, for example, and that will allow us to hopefully insert all of this stuff inside of our books. So if we actually go to the THM books that we have, if I do first, let's do describe, right? THM books, and let's see what describe to table. The THM book does not exist. Oh, excuse me. So describe, or what is it? How do we do it? I think it was show tables. Man, I already forgot. Hold on one second. Yeah, it was show tables. My bad. Okay, so here we go. Show tables, and we'll do that. And so we have books inside of the THM books database. There we go. So inside of that, we can do describe books, and then that'll give us these things right here. So we have an ID column, we have the name, publish date, and the description. And these are the various columns that we have inside of our books table. Okay, very good. So now we can insert into the books table the ID, name, publish date, and description, which is already been done for us. So I don't need to go ahead and change. Actually, no, I think this is how we add data to it. So if we do this, right? So if we do insert into books, and then we do ID, name, published date, and then description. So these are the fields that, or the columns that we want to be filling in piece by piece, right? So that would be the columns. And then now we want to add these values into those columns. So that's how this is going to work. And then the first value is going to be 1, so it's going to be ID 1. The next one is going to be Android Security Internals, and so that'll be the title of the book, the name of the book. And then the publish date is going to be 2014, 10/14. And then an in-depth guide to Android's security architecture, I guess, is the description of this thing. And then I think that's pretty much it, right? Yeah, so we can just close out the parentheses now and then close it out by doing a semicolon. And now we press enter, and it says arrow published data in field list. And it's not supposed to be published data, it's supposed to be published date. And by just missing that one little letter, I cannot insert, so I have to redo this whole thing. So forgive me and give me one quick second as I retype this whole thing out. There we go. And what's going on? So duplicate entry 1 for keybooks primary. So I guess the previous one, I guess, did work. What the heck, bro? What do you mean? Now oh my gosh. Okay, so I guess the previous one did work. So, all right, let's see if it actually did work here. So let's see, we need to read the contents, right? So the first, it's going to be selecting. Select is the keyword that you're going to use to be able to select an entry. And when you do select asterisk, it's going to pick everything. It's going to select everything from, and then from the books table. And we press enter. And I have Android security internals as Python 1, bug bounty bootcamp, car hackers handbook, designing secure software, ethical hacking, and ethical hacking. There are 2 elements of that. So we can technically get all of them, right? So you can select a given name, or you can select a given column. Instead of selecting everything from books, you can select a specific column from the book. And this can also be lowercase as well. So the uppercase thing is just for human friendliness, I think. So if I do select, and then from here we can do name and description instead of selecting everything. And then we will select it from books table, press enter, and it only now shows us the name and the description instead of showing us the ID as well, and the published date, and so on and so forth. So you can select everything by doing select the asterisk and then do from books, right? And it'll show you all of them. So it shows you the ID, the name, published date, or you can just do a selective portion of it where you say, I just want to see the name and the description from books, right? So that could be a way that you can display the content. And then we can update information that's available. So now we are in the U part of CRUD. So we've done C for create using insert, and then we've done R with read by using the select command, and then now we're onto the U for updating, and this one actually is using the keyword update. So in this particular case, where we can say, let's change the description of ID number 1, for example, right? So we want to change the description of ID number 1, which is the Android security internals right there. So we can go and say update books, right? And then you want to set the description, and that's going to equal to a guide to Android security, right? We'll just keep it short. We'll make it short. And then we're going to make that update and then we're going to set that description where the ID equals 1, meaning for ID number 1, I want you to set the description to this and update it. And now that'll be updated. So now again, we'll do select everything from books and then type that out. And then now we can see that a guide to Android security is the description for this first book right here. So the very first one where we wanted to create the Android security internals for ID number 1 and all that stuff, the reason why we got that error message that it already exists was not because the first time that I ran it, it actually went through. It was because these things are already pre-populated. So if I wanted to create another one, I could technically do an ID number 7 and then fill it in with a variety of different data. So we could actually go ahead and do that. So let's just create another quick entry into our books. So we'll do insert into books, and then we'll go ID, name, published date, right? And then description. And there we go. That'll be our new insert, and that's been all good. So now we can do select, select everything from books, and it'll display that we also have a ID number 7 random book, and this is the random book for demonstration purposes. And now we got that as well. So we were able to actually create an entry, and we were able to read by using the select command. And we can even updated again, right? So we can go ahead and let's say update this specific book's description. We'll update the book's description. So we'll do update books and then set description, and it'll be not so random, whatever. And then where do we want to make this update? We want to update it on ID number 7. There we go. And then we are now going to press enter, and that's been updated. So select everything from books, and we can see that it's not so random. So that we learned how to create by using insert into, we learned how to read by doing select, and then we learned how to update by using update. And now finally, we are at the D for delete. And of course, that is also a very simple command where we actually use the term delete from books where ID equals 7, because that's the one that I just created, and I'm going to press enter. And so now our last entry that we just created should be gone, and we no longer have an entry number 7. We have entry number 6. So we need to also delete that, because that is it's like a duplicate, it seems, where ID equals 6, and delete that. So there we go. Now we see that we only have one ethical hacking book that actually has the description, whereas the other one was just, it seemed like it was a duplicate entry. So create is done using the insert statement. Reading is done by doing the select statement. So select everything from books, for example. And then updating is done using the update statement, and deleting is done using the delete statement. So now we have a couple of questions where it says using the tools database. So the tools DB database. So if we do show databases one more time, we have tools DB. So we're going to use tools DB, and let me see. So we've already, okay, very good. So now we're inside of tools DB. What is the name of the tool in hacking tools table that can be used to perform man-in-the-middle attacks on wireless networks? So we are using the tools database. I do want to see the tables. So show tables, and it's hacking tools. So I want to select everything from hacking tools, and I have all of these entries inside of hacking tools. And we want the one that can be done, it can be used to perform man-in-the-middle attacks on wireless networks. So portable Wi-Fi for pen testing, malicious, multifunction for reading, writing, man-in-the-middle attacks. Let's see. There we go. So here it is. So number 3, a device used to perform man-in-the-middle attacks on wireless networks, and it's called the Wi-Fi Pineapple. Ooh, that's actually very interesting. I wonder if these are real I feel like they are. USB Rubber Ducky, LAN Turtle Bash Bunny. I feel like these actually are real tools that we have. So that's actually kind of cool. So Wi-Fi Pineapple is the answer for this one. So let's go over here and answer this question. So why, right? This is that's the right question. So Wi-Fi Pineapple is the one. Oh, I'm missing a dash in the middle. And then using that database, what is the shared category for both USB Rubber Ducky and Bash Bunny? So what is the shared category for Rubber Ducky, which is USB attacks, and Bash Bunny, which is also USB attacks? So we are going to say USB attacks are these shared categories. Okay, cool. Now let's talk about clauses. A clause is a part of a statement that specifies the criteria of the data that's being manipulated, usually by an initial statement. Clauses can help us define the type of data and how it should be retrieved or sorted. In the previous task, we already used some clauses like from, that is used to specify the table that we're accessing with our statement, and where, which specifies which records should be used. So we're going to focus on other clauses like distinct, group by, order by, and having. So the distinct clause is used to avoid duplicate records and so on and so forth. So now we're going to actually go back into our command line here, and we're going to use the clauses for various commands. So let's zoom in a little bit more here. And all right, so here we go. So the clause, the very first clause, I love saying clause. It reminds me of like the New York accent if you say it with that, like that Brooklyn clause. So the first clause is the distinct clause, and it's used to avoid duplicate records when doing a query. Now, unfortunately, so what I did was I actually I got ahead of myself, and for the THM books, I deleted that duplicate entry, and that duplicate entry was for the purpose of, so let me see, it was actually select everything from books. That's what we had. So that duplicate entry that we had at the bottom, which was the ethical hacking book, that was actually meant for the purpose of this exercise where we're supposed to pull the distinct records, meaning if you have duplicate entries, you only want to see the unique entries. So what I'm going to do real quick is I'm going to insert into books the new book, or that same book that we had previously, which was the ethical hacking book that we had. So let's do that real quick. Okay, so there we go. Now we can do show everything from books again, and we show select everything from books. And there we go. So now we have ethical hacking. So we can see this is what it looks like if we just use a distinct command, or if we don't use the distinct command, excuse me. If we just say show me everything, then it'll show us everything. So if we use the distinct clause now, then the way that it looks, instead of saying select everything from books, we're going to say select distinct from books, or distinct, let's say name. So we're going to do distinct name from books, and then press enter here, and we'll see that it only shows us the names that are actually unique. So it doesn't show two entries for ethical hacking. That's the whole purpose of using the distinct command. So if we went to group by, so this is clausing that aggregates data from multiple records and groups the query results in columns. So it can be helpful for aggregating functions, for example. I don't think we have a count that is available over here, but what we can do is we can actually aggregate, meaning we can count them. So this is what it would look like in that regard. So we would say select the name and then count it, right? Count and then just fill in the count for me. And then from books, and then I want you to group by the name and press enter. So now we can see that since we had two ethical hacking books, we actually have two ethical hacking as far as the count is concerned, and then the names are still there, and we have individual counts for each one of the books as well. But for the one entry that has two ethical hacking books technically, so the records of the books table are regrouped by the result of the count function, and we already know that ethical hacking was listed twice because we literally saw it. So the count for that would be 2, and then it's based at the end of this by the count, grouped by count portion, right? So we have now counted them, and count would, I think, is like an internal function that is inside of MySQL that actually does count for you based on whatever the title is, or whatever the specific identifier is that you've chosen. If we want to order them, so let's say we grouped by right now, we pulled first distinct using distinct, and then we grouped them by their title, by their name. So now we want to order them, right? So if we do select everything, and then from books, and then order by published date, for example, and ASC is the command that they've given us. So it says, and I keep saying published data, my goodness. So select everything from books, order by published date. Oh my goodness. Okay, very good. So there you go. And it has been ordered by published date, right? So you can see that over here. the order of these things has actually changed. So ethical hacking is no longer at the bottom. And then you can also just see by their ID number that they have actually been reorganized based on the published date. The ASC part, oh, I see. The ASC is for ascending, and then you can also order them by descending. So we can do the same thing basically. Select everything from books, and then order by published. Let me make sure I spell published date correctly. And if we do DESC, it would be descending, and then it will reverse the order obviously and give it to us by the most recent published, and then the oldest published at the bottom. So you can group them, you can order them by ascending order or descending order, and you would do it by either their name or their published date. Probably, I think published date, like, it actually makes more sense in this particular example. Doing it by ID could be another thing. So if we could actually do select everything, because it will literally show everything in ascending order by ID. So if you wanted to do select everything from books and then order by ID, and then do DESC for descending, and then do that, it would do the IDs in reverse order, right? So it would be 6, 5, 4, 3, 2, 1, right? So you can actually organize them by their IDs in descending order as well. And very good. Okay, so that's that. So we can now move on to the next clause, which is the having clause. And it's used with other clauses to filter groups or results of records based on a condition. So in the case of grouping them by something, it evaluates the condition to true or false, unlike where clause unlike the where clause, where having filters the results after the aggregation is performed. So if trying to kind of just explain it a little, it's easier to just demonstrate it. So if we do select a name, right, and then count them, and in this particular case, we would do the same thing where we would do the count in that regard, and then we're selecting the name from books, okay, and then we are grouping them by their name. And then what we want is to show something that having name like, and then this is where the piece comes in where, okay, I want you to show me anything that has a name that kind of resembles this, right? So as long as it has the word hack in it somewhere, I want you to bring me the result. So then it's going to bring us the Car Hacker's Handbook, and it's going to give us a count, and then it's going to bring us the Ethical Hacking Handbooks, and then it's going to give us a count. So it's very similar to what we did previously, where it was giving us the count of everything, but now in this case we're saying having a name like hack, so having a name that has this word in it basically. So if you're looking for anything inside of your records that you don't know exactly what the name is, but you know that the word is in there somewhere, there's like at least one word that's in there somewhere, then you can go ahead and order them. You can group them by their name and then display them as long as you know what word is in there somewhere. So having clause helps you do that. So that's basically it for all of the clauses that we had. So we had the having clause, we had the order by clause, we had the group by clause, and then we had the distinct clause that would show us the unique entries. So now what we can do is we can go back to the tools database so that we can actually answer the rest of these questions that we have here. So the first question is asking us, using the tools database, what is the total number of distinct categories in the hacking tools table? So we want the distinct categories in hacking tools. So what we're going to do is use the distinct clause, right? So we are going to say select distinct category from what was it? I think it was called Hacking Tools was the name of it. Yeah, Hacking Tools is the name of the table. So select distinct category from Hacking Tools, and then it says what is the total number of distinct categories. So we have 1, 2, 3, 4, 5, and 6. We have a total of 6. Oh, it also says 6 right here, so I didn't even need to count. So 6, there we go. That would be the answer for that. Sorry, I'm actually inputting it on this on my secondary window, but that's the answer right here for the first question. The answer was 6. So let's go down here just to show it to you so you know I'm not messing with you. So there we go. The answer for this was 6. Now it says using the tools database, what is the first tool by name in ascending order from the hacking tools table? Now we could obviously just do that. We can just look at it and kind of break them down accordingly, or it's probably best for us to actually run the exercise, right? So order them by ascending order so that we can see what the name is for that. So they want to see the first tool by name in ascending order from hacking tools. So what we're going to do is we're going to order them, right? So we're going to select everything, and then we're going to from books, or not books, sorry, from hacking tools, because I'm essentially just looking at the command that they used previously. So we're going to select everything from hacking tools, and we're going to order by name, and then it's going to be in ascending order, and that's basically it. And it's going to be Bash Bunny is going to be the first tool that's going to be on our list. So Bash Bunny, there we go. And now using the tools database, what is the first tool by name in descending order from the hacking tools table? So it's a very similar command to the previous one, except we're just changing it now to descending instead of ascending. So from I keep saying from books, from hacking tools, and then order by name, and then it's going to be in descending order, and that's it. So it's Wi-Fi Pineapple is the name of that tool, and we got to make sure that we put that dash in there, and there we go. So Wi-Fi Pineapple was that answer. Very good. So let's talk about operators now. So we already have used one of the operators. That was the like operator, where we were like, where the name is like hack. That was an operator that we used. So when working with SQL and dealing with logic and comparisons, operators are our way to filter and manipulate data effectively. Understanding these operators will help us to create more precise and powerful queries. And this is what we're going to be using the books table, and it's a part of the THM books 2, and we can access it with the statement use THM books 2. So the logical operators would be they test the truth of a condition and return a Boolean value of true or false. So let's explore some of these things. So the like operator is commonly used in conjunction with a clause like where in order to filter for specific patterns within a column. So we are now going to essentially just start running some of these commands here. So first we need to go to, it was THM books 2. So that's what we're going to switch to as our database so we can get some of these precise answers here. So it's going to be THM books 2. And then from here, we want to show tables. So we have the books table inside of THM books 2. Okay, very good. So now here we go. So we have select everything from books where description, okay, description, there we go, is like, and then here we're going to do guide, and let's see what comes up for that. So we have 4 entries that actually showed up. So it says an in-depth guide to Android security architecture, the guide to finding and reporting web vulnerabilities, a guide for penetration testers, and a guide for developers, right? So we had 4 entries that showed up where at least the word guide was inside of the description, okay? And that's how we do the where description is like something, right? So this is the like operator. And then we have the and operator. So this is where you want to kind of fine tune and hone in, right? So you want to find a very specific response. So in this case, we could do select everything again from books, right? Where the category, so let's say the category equals offensive security, because we actually have multiple in offensive security. And so I'll do that in caps lock so we can actually notice the difference. The name equals bug bounty bootcamp. Okay. And that's it, right? So now you have 2 specific identifiers, right? You have the two parameters for your search, where you have the category needs to be in offensive security and the name needs to be bug bounty bootcamp, and that's the only thing that you want to see. So obviously there should only be one thing that shows up, because there was only one entry that is also named bug bounty and it's an offensive security. So I feel like the name would just by itself would probably narrow that down a lot. But it is indeed Bug Bounty Bootcamp, which is ID number 2, and so on and so forth. So that worked exactly how we wanted it to. Now, we can use the other operator that also falls in that same line, which is the OR operator. So in this particular case, we used AND because we wanted to double down on our selectors, on our parameters, but now we can say OR, and when you do OR, it gives you either or, right? So we're selecting everything from books again, where the name is like, and then we'll do Android, right? Or the name is like, of course, the friendly of Android, the competition of Android would be iOS. So I want to see everything that either has Android in the name or it has iOS in the name, right? So show me either or. You press enter and it only gives you one entry because there's nothing inside of our list of books that had anything to do with iOS, right? But if we want to see anything that has to do with mobile devices, essentially, that's what this search parameter kind of shows us, is that search query is saying, I want to see any book that you have that has anything to do with mobile devices. And so it could be either Android or iOS. And in this particular case, we only had one book that was just about Android in our catalog of books. So now you can also narrow down the opposite direction, where you say, I want to see anything that is not this, right? So the not operator reverses the value of the Boolean operator, which basically makes you exclude something, right? So we can start the same way. And of course, it's coming from books. And then we were saying where not description. So meaning show me anything that the description is not like. And of course, we're going to say guide in this case, right? So show me anything that the word guide is not in the description is what I want to see. And so we can see a hands-on introduction to breaking in offensive security. And that's that's the only book out of the lineup of the books that we had that does not have the word guide inside of the description, right? So you can do this with essentially anything else, right? So it's like, show me everything where the name is not, or where not name. So right, where not name is like hacking or something, and then we'll see anything that has. So let's actually try it. So we'll do select everything from books where not name like, and then we'll do the word hack in it, and then we'll close that out. And so it'll show us 3 books because the rest of the books apparently have some kind of reference to the word hack inside of them, right? So it basically shows you everything that does not have that word in it. So our next operator is going to be the between operator. And the between operator allows us to test if a value is within a certain range, right? So to make it easy, you could technically do with dates as well, but it would be a little bit more complicated to try to write it for the dates. So we're going to do it with the ID. So we're going to select everything from books where the ID is between 2 and 4, and then just press enter, and now it's going to show you 2, 3, and 4. Very, very simple. But you can also do it with date ranges as well. You could do it with page counts, assuming that we actually had a page count column that showed us how many pages these books were, and then we can say, yeah, I want to see all of the books that have between 100 and 150 pages, right? So that would be another way that you can narrow it down using the between operator. So those were all of our logical operators. Now there's something also considered the comparison operator. So where you say, I want you to show me something where this equals to this, right? Or where this does not equal to this, or where this is less than this, or where it's greater than this, less than or equal to, greater than or equal to, right? So on and so forth. So we are going to start with the very basic one, the very first one, which is going to be the equal to operator. So select everything from books where name equals to designing secure software. Okay, there we go. Press enter and it gives you that one entry where the name is equal to designing secure software. So you could do select everything from books where name is equal to Car Hackers Handbook, right? Boom. And then you see Car Hackers Handbook. So very, very simple, very basic. And we could do the same thing, right? Select everything from books. So meaning select all of the columns from books. That's what that means, not all of the entries. So select all of the columns from books where the ID is equal to 5. Oh, whoops. There we go. And I forgot to close that out. So I wonder if this is actually going to work. Okay, yeah, that was an error for sure. That was a bad query. From books where the ID is equal to, we'll do 5 like that. Or let's do a space just to give it a good round off right there. And there we go. Now we have the 5th book. So you get it. You get the idea here. So that was equal to. So just like we have equal to, we can also do not equal to. So we can do select everything from books where the category, and the way that we do not is by doing an exclamation. And this is pretty consistent across most languages as well. If you do exclamation equal sign, that means it's not equal to whatever it is that we want. So I want you to show me something that is not in the offensive security category. And then now it only shows me 2 items that are inside of defensive security, right? So show me all the books where the category is not offensive security. So that is the not equal to comparative operator that we have, which is the exclamation and then the equal sign, and that would be not equal to. We have another one, which is select everything from books where the published date, so this is where we can go into less than. So the published date is before 2001, so 2020. So show me anything that is before 2020. So you press enter on that and it'll show you 2014 and 2016, right? So you can do the same thing with greater than. So we can say, now I want you to select everything from the books and then show me where the published date, let me make sure I do that right. So published date is greater than the 2020, right? So I want you to show me that came after January 1st of 2020. And of course, it shows us all of the books that came after January 1st, 2020. We can also do less than or equal to, right? So if you actually have a specific value that you know is either, again, we could be the page count, we can do the published date, because that seems to be the only thing that we could really measure like that. So we can do select everything from books where the published date is less than or equal to, and then we can do 2021-11-15, and that will show us anything that's equal to 20 or less than or equal to 2021-11-15. So November 15th of 2021, as long as it showed up on or before that date, right? So if it shows up on or before that date, I want you to give me those results. And of course, we have the 11/02, which is before 11/15, right? So 11/02 2021. So it's technically before 2021-11-15, and then of course 2016 and 2014 are also before 2021. And then we can just reverse it the other way, where we just do greater than or equal to. So select everything from books where published date is greater than or equal to, and then it would be 2021-11-02, and then close that off, and now it will show us everything that is on or after 11/02, right? So 11/02 right here, this is actually on that date, and then these are all after 2021-11/02, right? So you have equal to, not equal to, greater than, less than, and then greater than or equal to, or less than or equal to, which all are our comparative operators. Okay, so now we can actually start doing some hunting for the tools database one more time. So here we go. And so inside of tools database, we had the table was hacking tools. Okay, very good. So now it says inside of the tools database, which tool falls under the multi-tool category and is used for pen testers and geeks. So for the multi-tool category and is used for pen testers and geeks. So let's see. Let's see what I can see here. So first, I just want to see what the various columns are. So selecting everything, we have ID, name, category, and description. I see. So okay, so for pen testers and geeks, we can search by the name, we can look for category, and we can look for description. So most likely we're going through the category as well as the description, it seems like, because there's nothing here that says, because for the, let me see, the way that the question is outlined, oh, it's the multi-tool category, so my bad. So it's under the multi-tool category, and it's for pen testers and geeks. But I mean, what's interesting is that there's literally one thing that's inside of the multi-tool category, so I know for a fact that flipper 0 is the answer. I just know that. But what we want to do is we want to actually write a query that will bring that up for us. So we're going to use the where, we're going to use and we're going to try to craft something that's pretty solid here. So it's going to be select everything from hacking tools, where category equals to multi-tool, and description equals, or description is like, I think that's what we could do probably. And we can go in here and do pen testers and geeks, and then close that off. And let's see if that works. That worked. Excellent. Okay, so because we know that pen testers and geeks should be in the description, but we don't know where the full thing would be. So we want a description that is like that. So we want this to be inside of the description at some point. And we also want the category to actually be multi-tool. And of course, that was flipper 0. I'm very, very happy that that worked. Super excited about it. So let's come down here. And then we're going to do flipper 0. And now the question here is, using the tools database, what is the category of tools with an amount greater than or equal to 300? So what's the category of tools with an amount greater than or equal to 300? Okay, let's see. Got it. Okay, so we actually have an amount column here as well. This is kind of like crashed in together, so we can't really see it, but these numbers right here, that's the number of the tools, the quantity, I would say. So these are the tools that we have. And so inside of the amount section, or the amount column, what we're looking for is the category of the tool that is greater than or equal to 300. So greater than or equal to is that. So first we're going to do select everything from hacking tools, and it's going to be where amount is greater than, there we go, greater than or equal to, and we were going to say 300 and press enter. And so we have iCopyXS, and then we have Proxmark3 RVD4. So using this, what is the category of tools with an amount greater than or equal to? And that is RFID cloning. That is our category, RFID cloning, not clothing, cloning. Very good. And so using the tools database, which tool falls under the network intelligence category with an amount less than 100? So we are going to combine a few things. The first one, as always, is going to be select everything from hacking tools. And now we want where amount is less than 100, right? That's what it was. So where the amount is less than, let's do less than, there we go, 100, and I'm going to put the 100 in quotes just in case. And what was the other thing? The category equals to network intelligence, and or I think the I in intelligence is supposed to be, I don't know if it's case sensitive like that. Well, let's see. Okay, so we have it. So land turtle is in the network intelligence category, and it has less than 100 in there, and that would be our answer. Very good. So land turtle. Excellent. Cool. We got all the answers, and we can now move on to functions. When working with data, functions can help us streamline queries and operations and manipulate data so we can see what these things can actually do. This is a little bit different from everything that we've gone through so far. So we have the concatenate function, which is used to add 2 or more strings together. We have the group concatenate function that helps us concatenate data from multiple rows into one field. And then we have the substring function that will retrieve a substring from within a query. We have the length function that will retrieve the number of characters in a string. And then we have aggregate functions, which is the count that we already did once, or we actually did it a few times, that returns the number of records within an expression. We have the sum function, the sum of all values not null of a determined column. So there's no need to execute this. This is just for example purposes as they tell us. And then we have the max function that calculates the maximum value within a provided column, and the minimum function, which does the opposite of that. And then we're going to run these things inside of the tools database. So for the purposes of this specific thing, it's not giving us any of these things to exercise within like the books database, for example. So what we're going to do is I'm just going to go through the descriptions of this, and then we're actually going to run them to get the answers that is at the end of this task. So the string functions perform operations on a string, returning a value that's associated with that string. So concatenate is used to add 2 or more strings together, and it's useful to combine text from different columns. So let's say that select concatenate name. So you're going to concatenate the name and say is a type of category book, and as book info would be the from books. So we could technically do this with the tools database that we have right now. So let's just do it inside of where we are right here. So instead of doing it with the book, obviously I will just do it with the tools that we have. So we're going to say select and then concatenate, so concat, and then we're going to say name, and then comma, space, and then so this part is literal. So everything that's inside the quotation is literal. So you need to do quotation, space, and then we're going to say is a type of, right? And then space again, and then quotation. So that would be a literal string right there. And then we're going to do category. So this tool is a type of category tool, like that. And then we'll close that off. And then this is going to be as tool info from hacking tools. And there we go. So it says Flipper 0 is a type of multi-tool tool. OMG cables is a type of cable-based attack tool. Wi-Fi Pineapple is a type of Wi-Fi hacking tool. So it's nice. It's like it's functional the way that this actually works, right? And we can do this not with just individual fields, because technically this is individual fields that we're putting the name along with the category, right? So we can do this as a group concatenation, where we say, what is it? The group concatenation is a function that helps you concatenate data from multiple rows into one field. So an example would be what they did was select category, and then group concatenate name separator as books from books, and then group them by the category. So that's basically what they did. So what we can do here is we can do a similar version where it's like select category and then group concatenate, and then we will do the I'll just do the same thing that they did. We're just going to pull it from this group in particular. So we're going to group them by their name, and then separator is going to be the comma with a space behind it, and then it's going to be as tools, and then we're going to pull it from the hacking tools and group by category like that. Press enter. So what do we have? We have their names are here, so this is all good. And then cable-based attacks, multi-tool network intelligence, RFID cloning, USB attacks, and Wi-Fi. And then so I see. So this is what it looks like, right? So for RFID cloning, we have iCopy and we have Proxmark. And then for USB attacks, we have USB Rubber Ducky and Bash Bunny. And so they have been categorized, they've been concatenated by their group, right? So we can see where they fall into as their category itself is concerned, and then which books fall into those categories alongside them. So cable-based attacks only has this tool inside of it, multi-tool has this inside of it, network intelligence has this, and then RFID has these two, and then USB attacks has these two, and then Wi-Fi hacking has Wi-Fi Pineapple. So this is a group concatenation. This is actually very useful as well. It's just a different way of organization, which I think is very handy, especially if you get into much larger databases and you're looking at tables that have a lot of data and you want to see how these things actually kind of break down. This is something that we would have to practice a lot more though, so that we can kind of internalize and memorize it. So another thing that we can do is the substring function, which will retrieve a substring from a string within a query and starting at a determined position. So the length of this can also be specified. So for example, let's say we are trying to pull the, in this particular case, it's for the published year. So we're dealing with tools here. So there's no published year or anything like this that we have here. We just have the name, the category description, and the amount. So that unfortunately is not going to work for the hacking tools. So I'll just show you what it looks like on the actual example that they gave us here for the books. So the selecting of the substring from the published date, and then you have 1 and 4 as the published year from books. So it's going from the first position to the fourth position, meaning 1, 2, 3, 4, like that. So it's going to take those 4 characters from the published date, and then it's going to give it to you as your published year from books. And this is what it's going to look like. So we can observe how it extracts the first 4 characters from the published date column and stores them inside the published year. We have the length. So selecting the length of the name, for example, as the name length from books in this case. So we could actually run this, and it basically just counts the number of characters of the name. I'm actually not going to do this because this one's really basic. So you're basically getting the length, and in this particular case, it's also going to calculate the space, I would assume, because that actually counts as a character. When you're doing a character counter, the space also counts as a character. So the query calculates the length of the string within the name column and stores it in a column named name length. And this is what we see over here. And then we have the aggregate functions, which have to do with the value of multiple rows within a specified criteria in the query, and it can combine multiple values into one result. So we have the count function that we've done multiple times. So select the count as total books from books, and it's giving us the total number of books, which is 5 books in this particular case from our, I think it's like THM books 2. I think it's from that database. So it counts the total number of rows in the books table, and the result is 5, as there are 5 books in the books table, and it's stored in the total books column. Then we have the sum function. So we're not going to execute this because it's for example, and it says select the sum of the price as total price from books. So it's essentially calculating the price of all of the books combined. So if you sold all of your books, this is what you stand to make essentially. So it calculates the total sum of the price column. The result provides the aggregate price of all books in the total price, in the column total price. And then we have the max function that calculates the maximum value within a provided column in an expression. And then you have the minimum function that would calculate the minimum value within an expression. So we could technically go for the count, right? And we can take the maximum count, or we can go and get the minimum count. So I'll try to do that right now and see what we can do in this particular case. So let's see, we're gonna go get the maximum count of these guys right here, and it's going to be in the amount column. So it'll be select max, and then it's going to be from the amount column as we'll do most amount, and then we'll do from hacking books or from hacking tools. And there we go. And now we have the one that has the most amount is going to be the 375. I don't know what item it is that actually has 375. It would probably be good if we actually were able to pull the name as well. And I'm sure we can. It's just that in this particular case, we did the maximum, and we're getting the amount from hacking tools. And I can probably just combine this with like and select name, right, from hacking tools. So we could actually do it like that. So I'll try it. So I'm going to do select max amount as most amount and name from hacking tools. Let's see if this actually works. It says you have an error in your syntax. Check the manual that corresponds to your server for the right syntax and name from hacking tools. So I guess that was not the correct syntax. So yeah, I'm not gonna go down this rabbit hole just to save us some time and energy. But the max one worked, and then of course the minimum will also work as well. So if I did select min amount as least amount from hacking tools, then we'll be able to pull the one with the least amount, which is 80 pieces. So all right, there we go. So our final set of questions here is using the tools database, what is the tool with the longest name based on character length? So we're going to go pull the character length, and right here. So we're going to select name as name length from books. The thing is though, like I want to be able to pull them from the longest name. So let me see how we could actually do this. So we were so close with this. I was so close with this. So I think it's select name, comma, and then max amount as most amount, and then we'll do from hacking tools. Let me see if this works. I hope this works. It still didn't work. There's something that I'm missing. I feel like I'm so close though. So I think for this, it could probably be like select name, comma, length of name, and then as name length from books. Let's try that and see if it actually works, because that would be one. If I figure this out, I would be super excited. So if we do select name, comma, and then length of name as name length from hacking tools. That worked. So I wonder why the max amount thing doesn't work. Maybe it's because it's like it's an integer calculation kind of a thing. Maybe that's why it's not working. But the name and then lame length actually did work. So the longest name is the USB rubber ducky, based on the count right here that we have over here. So let's go over here and we'll do USB rubber ducky. Oh, maybe the freaking hint could have helped me too. So let's see, it says use the length function and sort the tool name in descending order. Oh, I mean, I could have sorted that too. I didn't even sort it. I just counted it. How would we do the sort? Now I wanna sort it too. It would be by not the group by, it was the order by. So it would be by the order by, and then we can also order. So we can basically do the same thing right here, except what we would do is we will do select name, and then we will do the length of the name as name length from hacking tools, and then order by name length, and then descending order. Wait, is it order by? Hold on. Am I misspelling order by? Yes. I am definitely misspelling order by. Can I press up and take that? Oh, very good. Okay, so we can do that. It's order by is not separated by a underscore. There we go. Hey, there we go. That worked. Okay, great. So, all right, we're getting some complicated, complex queries here. So select the name and the length of the name as name length from hacking tools, and order them by the name length descending order. And then so that's what we got right here. And we were able to actually do what the hint told us here, which was to sort the tool in descending order. So very good. Okay, cool. So the next question here is use the tools database. What is the total sum of all tools? Which is for our amount right there. And we're going to be able to just do select sum price as total price from books. So we are going to, I'm just going to type it right here. So it's going to be select sum, and it's not select sum of the amount as total count, and then from hacking tools. And there we go. 1,444 is our total count. So let's do that. Very good. And then using the tools database, what are the tool names where the amount does not end in 0, and group the tool names concatenated by and. Oh my gosh. Okay. All right. So where the amount does not end in 0, and group them concatenated by and. That's unbelievable. All right, so I know that we are going to be needing the substring portion of this, and we're also going to be using the group concatenate, which is right here, and then we are separating with the ampersand as they requested. So we're kind of combining, or not kind of, we're actually combining two of these things to make this work, okay? This is what I think is going to be our yielding query. I think this is what the final query is going to look like. So first we are going to select from the group concatenation. So we're going to concatenate the name of the group, and the separator is going to be the ampersand. So I need to put that inside of the, my God. Okay, here we go. So there we go. So it's going to be, we're first going to group concatenate the name, and the separator is going to be the ampersand. And then we'll just put it as the names, whatever. And then we're pulling this from the hacking tools, so that's fine. That part is easy. This is where the part that is kind of the tricky part that I didn't know really what to pull from, and it kind of makes sense because it's similar in Python as well. So the substring is what we're using, and we're looking for the amount. So we're looking at the amount value, and we want the last thing. So when you go from 1 to 4, so if we look at this right here, you see right here is looking at the first character and it's going to the fourth character. But there's a way that you can come from the end of the value and come from this last one and come backwards instead of going forward. And the way that we do that is by using a -1. So if you do a -1, then you're looking, okay, let me just make sure that I can do, okay, there we go. So a -1. So when you do a -1, you're coming from the last character, and then we're coming in 1. So we were literally just looking at that very last item on the amount, and we don't want that to be a 0. That's basically it. And this is the string right here. So this is the part that it was kind of a little bit tricky for me to figure out. And it's trying to find out how to designate the last character of the amount. And so if we start at a -1, we're looking at the very end of the value and coming to the left, right? So if we're looking at this as the end of the value, coming 1 character to the left, that means you're coming from the -1 position, coming 1 to the left, and now you're looking at this very last item. And we just don't want that to equal to 0. So fingers crossed. Let's see if this actually works. And it did. Look at that. So the flipper 0 and icopy S were the ones that were not ending in 0. And then we combined their names together by separating them with the ampersand. So the group concatenate part of it is kind of, it's like the simpler part of this specific query. It's this piece right here that, for me anyways, it was a little bit confusing. So this is how we do it. So we have the -1 that implies that very last character coming in by 1 space. So that ends up looking at the very last item. And then as long as that's not 0, then we would be all good. So that would be the flipper 0 and the icopy XS. So now we can copy this, and let's hope that that's actually the answer here. And it is. That is very satisfying. I very much enjoy when things like this actually work. So that was it for our SQL room. I was actually very, very happy with that because I learned a few extra things that I did not know before. So I hope you also learned from this particular video and this particular room that we were in. It is not a free room, so you do need to have MySQL on your computer if you don't have TryHackMe. You do need to have MySQL to be able to run the exercises that we ran. But I mean, for the most part, it was fairly easy to wrap your head around as long as you just follow the instructions. So, you know, feel free to replay each segment and go through the whole thing just to really, really wrap your head around it, because this is very, very powerful. SQL in general is a very, very powerful tool, and it's a very language to learn, a good language to learn, because you end up using it in so many different environments. So I hope you actually found a lot of value out of this particular room, because for me, it was very, very useful. And of course, if you did find value from it, make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially in the CySec101 training series as we continue to go through it. And drop a comment if you have any questions. I know this one was a little bit complicated for me. It was, at least. So I don't know what your strength level is when it comes down to SQL. But for me, I was going through a little bit of a learning curve as I was trying to explain all of it for you. And I'm glad we just achieved success by the end of it. So if you have any questions, drop the comment in the comment section. I will definitely respond to your comments. And of course, just make sure that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And drop a comment if you just want to say hi or if you want to say thanks. And of course, you can always support this channel by joining the Hackaholics Anonymous community, the premier community for security professionals and hackers. We have 4 tiers: the Cyber Supporter, Agent, Guardian, and Master. And each tier gets their own Discord server and early access to content. And the Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that's it. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. I hope you found this video useful. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video. Later.